Work it, make it, do it, make sense.
Well, welcome. I've got to stand over here. Welcome to Anatomy of the Java Vulnerabilities. By the very nature of this, we would like this. Sorry, I'll introduce us in a minute, but make it as dynamic as possible. Ask questions because there's a lot of dry stuff and there's some scary stuff. So, through weird circumstances, the only slide about speakers is me. So, my name is Steve Poole, work for IBM. I'm a developer advocate now for the runtimes team. I spent a couple of years prior to that being a lead engineer for DevOps. I've been Java and open source and stuff like that. So lots of, from this talk's point of view, I've seen it on both sides from a Java internals point of view, but also sort of as a customer and understanding some of the issues concerned. And Tim, who's standing here prettily, would you like to just give an introduction?
Sure, thanks, Steve. So I'm Tim Ellison, and I look after the Java runtimes team at IBM, so I'm working with Steve. I didn't do that detour into DevOps. I've been in the Java and runtimes business for many, many years. We kind of submitted this as a joint talk, but I've been off traveling around working some other stuff out at the moment, so Steve has kindly agreed to lead this talk. I'll just be chipping in from the sidelines and asking other questions and different stuff.
But I could brain dump. We could brain dump to you all about this stuff, and there is some dry stuff, but actually I'd be really interested in your feedback and your questions about this, because it's an important topic to talk about. Right, so it's part of this talk is technical, and part of this is the scary stuff. The scary stuff will be in black, not necessarily with eyes, and the technical stuff will be the standard DevOps stuff. Okay. So let's start with the really straightforward thing. What is a vulnerability? So let's talk about the wording, right? So generally people talk about vulnerabilities as being bugs which can be exploited, right? I found a bug in your code, and people can use that bug to do bad things to you. So the primary things are like attacking your vulnerability, your availability. So you have a bug, somebody finds it, somebody exploits it, and they make you crash. They crash your system. Your system is down. You recover, they make you do it again. You know, that's where you get ransomware. That's where you get denial of service things, right? Whether it's crashing it, some exploits that will actually use all your memory up, reduce your, hog up your CPU, deal with your network, reduce your networking use, just bash you over the head by using exploits against you, right? So that's availability. So looking for bugs in that space. They're also looking at the integrity thing, which is, can I get in and modify your data? Can I find exploits in your code where you run something, and I find a weakness where I can get your code to run something else, right? And then, of course, the one that sort of probably gets the most press is vulnerabilities that expose confidential information or any sort of data. So privilege elevation is the idea of I can find a way to get root access to systems, through some vulnerability they discover in your system. But confidentially mostly is about where you think you've secured your data, but actually they find a way of getting at it. And you might have heard about SQL injection vulnerabilities and those sorts of things where they just pull out the data. So first thing you should think about is, why should you care? So you talk about Java vulnerabilities, they get fixed, you get these updates. Okay, why should you care? What's change? So I said I'd give you some scary charts. Cybercrime realities. There's a real perception, which hopefully is beginning to change, that the people who are hacking, the people who are finding and exploiting these vulnerabilities are lone individuals. They're just people out there in their bedroom, doing it for fun, for profit, but they're not. How big a problem is this, right? So let's set the scene. Organised crime is the most profitable type of crime in the world, right? 2016, so last year, it was estimated to be $445 billion a year. That's how much the criminals were getting out of this, right? So I'm not even talking about espionage or cyber warfare. This is just the crime bit, right? So $445 billion a year. The illicit drugs trade, according to the UNO, it was 435 in 2013. Numbers not perfectly easy to calculate, but you can see they're on a par. So 2016 versus 2013. Which one has the least risk to the criminal? Cybercrime. Which one is growing the fastest? Cybercrime. The expectation is that by the end of 2020, that will be 2019, $2,100 billion. So $445 billion is like 1% of the world's GNP. It's going to be 3, 4, 5%, right? So it's a massive problem, okay? And basically, prosecuting these people is almost impossible. Turns out that pretty much everybody who gets arrested for cybercrime doesn't get arrested for cybercrime. They get arrested for another type of crime, and then we discover that they were actually, doing something in the cyberspace. So it's totally lucrative, you never get prosecuted, and they make loads of money. That's why you should care, because these guys are coming to get you. Now, the other thing about vulnerabilities is it's not a smoking gun. There's not this situation where you can say, look, I can see an obvious thing in a piece of code where it is a bad thing. Alarm bells go off. Finding them, there are people who go out and find these things, which we'll talk about. The actual, an exact example of a vulnerability, and I have some, you look at those and go, why is that a vulnerability, right? Why is that important? So let's have a really simple one. So this one is fixed pretty much everywhere. But I'm going to talk about it at this level because it is not a good thing for us to talk about the details. Because even if I said this was fixed in all versions of Java apart from 1 or 2, I would then be saying that those 1 or 2 versions of Java are still vulnerable and you could go find it. So we're not going to do that, right? But let's talk about this one. This is really clever. Properties object maps labels to class names, right? Decode equals use this class, right? When the code was called, if the code which pulled out the stuff out when it tried to instantiate the class from this label, when it wasn't there, this nice message got sent back. And it said, I can't instantiate decoder, and here's because it's got this value and I can't find that code. And you go, why is that a vulnerability? Right. So the vulnerability comes from when people exploit that. Because if the property that you were looking for wasn't in the properties class that you were calling, the code would actually then go off to system properties. So somebody could pass in a label saying, please give me user.home. The system will try and instantiate it as a class, doesn't exist, and it will give you back a nice message that tells you, can't find class users Joe. So you might think that's not a bug. You might think that, in fact, that is a feature or a helper, right? You were just helping the people understand what their problem was, but it got exploited, right? That's how vulnerabilities work. They are people finding ways that your code behaves and finding ways to get around those, okay? So that's what a vulnerability is. I told you about the scale of the problem. It would be worthwhile just quickly making sure that you understand who the bad guys are. It's not these guys. This is from 1920s. They're just random bad guys. They're you. Sorry, they're not you personally. What we know about the people who are exploiting these vulnerabilities, the cyber criminals, they are very organized. They do agile. They do scrums. They share things. They're really, really good because they're very motivated. Okay. They tend to be people who are coming into IT, so they are people who are learning about computers. They go to conferences, they do online courses, they learn all the stuff they need to learn, and then they apply their brain in a different way to break your code. Okay? And we know, as you can imagine, that when you have cybercrime, they're targeting a range of people. Right? That's fine. We know about the fact that they're going to be going against people who've just joined the company because they're confused, people who are frightened. There's a whole bunch of phishing scams that are out targeting individuals. But they go for us too. They go for developers, right? They go for the people who are weak and vulnerable and ignorant, okay? And the reason that they go for us, the reason that we are a good candidate, is because of what we can do. So we know how it all works. We write the code. We tend to have pretty good privileges. We're very over-trusting. We use people's code without looking. We are very good at making use of other people's code without even worrying about vulnerabilities or even about providence or anything about this code. We trust people to just do the right thing. And I hope when you see this, you'll start to think about, when you're using other people's code, you're starting to think about what are the vulnerabilities in that code? What do those guys think? Is it being updated? Do I hear anything? Do I see activity in that space? Right? We are very poor as a community in terms of how we worry about security matters. Right? So, which is why I say we're weak, vulnerable, and ignorant. Right? We do this. We are targeted. And if you don't agree, how many people have done this? How many people have Googled for words like this? How do I find getting Java to accept all the certs over HTTPS? How do I trust any SSL certificate? How do I disable certificate validation? Okay. Everybody does that because we've all had that instance where we want to get access to something and there's a self-signed certificate or something that gets in the way and it's just painful. So we do this. This is the really important bit is is client trusted, return true, right? We do that because we don't think about the consequences, right? So a takeaway from here is for you to think about when you're writing code that you are aware of the security implications of what you're doing, right? And we're not going to educate you about security and how to write secure Java code. There's lots of stuff on the web to do that. This is about just trying to get you to think about it, right? So vulnerability is a bug, for sure, if they can find it, but it's also features that you've put into the code, right? Because you think it's a feature doesn't mean that it's not vulnerable, right? It is. They will make use of how you've coded and find ways around it, right? There are people out looking all the time. So we have researchers doing it because it's very good that we find those as soon as possible and get them fixed, because it's better that somebody who's on our side finding the vulnerability is better than having one of the black hats find it, okay? But everybody is scanning, right? It is a big business, right? So when you've got a vulnerability, right, and of course, if you're a commercial software or open source software, vulnerabilities are just, part of life now. There's a process, how do you deal with them? So the world has got together on a lot of this, and there are some commonalities about how they're reported and how they're tracked. So I'll go through that. So we'll do the process bit first. So there is a word that you'll hear about, it's called an acronym called CVE, Common Vulnerabilities and Exposures. This is important. There's a website, cve.mitre.org. It's the primary one. There are a couple of others. If you want to go read about CVEs, about vulnerabilities, go there, right? Look for CVEs. It's a community that's got together. It's all the people who care about this. We want to talk about vulnerabilities so that you understand that a vulnerability has been fixed. We need to have a standard naming convention, a standard reference, so that we understand this bug has been fixed or this vulnerability has been fixed. Okay. So you can go to this website and you can search. So I did. It's a mixed thing here. So you can just search. So I searched for Java as of this morning. I got 1592 CVEs. I did Java Serialisation, a perennial provider of vulnerabilities, and I got 12. These are just example lists which I didn't update, but you can go get these stuff yourself, okay? So if I go to Java Serialisation, so if I go to the website and I search, so as of this morning, because this is up to date, I went and said, what do you know about serialization of vulnerability CVEs? And the top three, right? No particular order, just the top three that came up, right? And so here you can start to see how vulnerabilities are described, right? What they're in, some information, right? If you dug down into one of these, so if you dig down into, I don't know, let's dig down to the middle one, right? Unspecified, right? this is all you're going to hear about that vulnerability. Right? So the challenge for us as a community is you may be interested in what's the code for that vulnerability, but nobody's going to tell you about it. We're going to go to lots of lengths to ensure that it's hard for you to find that out. Okay? And that's a very common unspecified vulnerability. And if you try to go from that wording to the code, well, you could probably find the diffs, but because of the type of what a vulnerability is, you're never going to find the smoking gun. Nobody can say, I fixed this so bad guys can't access this thing. It's not going to work like that, okay? So the question is, how would you assess them? How do you know which are the things you need to look at? Which are the ones that you need to get fixed? So apart from there being a website that lets you see how they are, common tracking processes, there's also a scoring system that goes with it, which is the CVSS system. Okay. The interesting thing about it is, we talk about, and I'll explain in a minute about the different complexities of a vulnerability. There's all sorts of assessments. One of the things that you have to remember is that there's a temporal access to this as well. So it might have a low score today, but it may have a high score tomorrow. Oh, BBC. So when you're looking at this, you need to also look at how it's progressed, and there are places you can go to see the score change. I'll go through a little bit about the details in a second. So the thing again is that we have a common place to go find them. We have a common scoring system, so you can see the impact. Right? And if you look at that in more detail, you can see here are the basic classifications. It's like all these. It's like a risk assessment. Right? What's the attack vector? How hard is it to get applied to you? How easy is it to exploit? Is it really simple, or does the person having to exploit it have to work really hard? I don't know, what sort of privileges do you need? Is it, again, it's about, there's this combination of attributes of a vulnerability will tell us whether it's important enough to get fixed quickly or slowly, because everybody has to put developer effort in to fix these things. So this gives you the ability. So you can go off into any of those CVEs and you can see what the list is. You can go see the score and see the details, right? And you can start to assess them yourselves. It's something you need to start getting your head around, because you can't just go, fixes have been applied to Oracle version blah, that's fine by me. You need to be getting into the process of understanding why and whether you need to move to the next version of Java or not, based on what's in these impacts. And you need to be assessing whether not just the critical ones, but some of the lower ones are actually things you need to assess. Right? So anyway, you can get scores, and then you can make decisions based on what these guys say. They work on the assumption that you are sensible human beings, and that if you, for instance, gave everybody in your machine root access, then this thing doesn't work for you. You're just generally stupid. Right? Okay. So how they're communicated. So we've got a process, we've got commonality, we've got scoring. There are a whole bunch of ways, right? So Oracle have the CPU advisory, which you can, emails, lists, etc. IBM does the same, blogs, notifications. We are publishing all the time what's going on. As I said, you won't get to see the detail. You'll get to see CV descriptions and scoring, right? And that's all you're going to get. But I think it's important that you understand that you need to be applying these on a regular basis. You cannot ignore these sorts of problems, right? So we don't talk about the details, because I like if we were to talk about the code, the vulnerability, or the fix, if I talk to you about the fix, you could work out what the vulnerability is. It's exactly the same as me tweeting my credit card and PIN number, right? I'm just giving it away to the bad guys if I say, look, I found a vulnerability, right? Which is why we try not to do that. There are times when they do get published. Some of the people who report these get very upset they're not being fixed, and they go public, right? Which doesn't really help anybody. So Oracle have their CPU updates, and they have these version numbers, odd numbers, so you can get into the habit of going, it's a security fix, I should take it, I should take it, I should take it. IBM does similar sorts of stuff. Chat about that. Oracle tries to do everything at the same time. They have the same cadence, right? Just do it. It's a security update. The advantage of having that regular upbeat is that you, from an IT point of view, can say, right, we will be doing that. We will be applying that on a regular basis. So everybody gets lined up, and it happens fairly regularly and fairly quickly. The IBM has a PSIRT, the Product Security Incident Response Team, which has been around for ever, I think. It's not just a Java thing. IBM obviously is very careful about security. It's something we focus very heavily on, and so there are lots of activities going. We have the, I'm not sure I got the slide of it, but we have the X-Force as well, which is a research group that is out basically knee-deep in this, or neck-deep in vulnerabilities, and finding them and reporting them as quickly as possible. So that's basically ours. We're going to try, obviously, get ours as close to Oracle as possible. Same sort of thing with version numbers. There's a pattern. You can go use this stuff, right? So, anyway, let's process. Let's move on. How are they being found? Who is finding the vulnerabilities that are being fixed? Right. At one level, it's basically large companies or product companies are doing it. Third-party researchers. So there are lots of good people out there, the white hats, who are doing it. They're finding these vulnerabilities and they're reporting, because it's an important activity for everybody to do that. And of course, the bad guys are doing it as well. Right? So product teams, white hats, researchers, and the bad guys are all out there trying to find the vulnerabilities to get them fixed, so that you can apply the next version of Java, so you're not vulnerable, so you don't lose money or information, right? So we're all trying to working together on this. So what about if you found one? What should you do? Right. So the basic thing is report it. Right? If you think you found a vulnerability, do let us know. Right? Don't ignore it, don't hide it. Don't shout about it, right? Don't stick it on Facebook and say, hey, I found a vulnerability. When you do this and this and this, I can bring your system down. Please don't do that, right? Just report it. You can go to the CVE website and report it. You can go to pretty much all the corporations and go, I found a security. I think I found a vulnerability. Report it, okay? But as I said, you won't be looking for smoking guns. You'll be looking for those circumstances where if you do X, Y, Z, you bring the system down. You do X, Y, Z, and you find a hole, okay? And then, of course, however we find them, in the end of the day, we're going to fix them as quickly as possible. But obviously, we don't have all the resources to fix all the bugs all the time, which is why you have the scoring process, so that you can see that if we assess a vulnerability as high, you need to get it fixed, right? We're not doing it for anybody else other than you, and a lot of effort is going in to give you secure systems. How vulnerable is Java? So the reason this talk exists is because one of the guys I work with, and Tim works with, who is knee-deep, he'd spend all his time working on Java vulnerabilities. We were chatting about whether people would be interested in a tool like this. And I said, so isn't it just security, just plugins? And he went, no, there's a lot more than that. And over the last few months, we've been digging through it and going, actually, no, it's quite interesting. So how vulnerable is it? Well, we have a poor reputation, that's for sure. You know that the press hits Java over the head and says we're as vulnerable as Flash, etc. It did get bad, but that wasn't really our fault. It was the fault that Java, right at day one, didn't really think about security. And in fact, pretty much in the beginning of the internet, people didn't think about security. Most of the vulnerabilities that we get are actually, number-wise, are going to be plugins and things like that because of some really intrinsic design problems. But because that's pretty much gone and people don't use that, you might think that Java is actually really good and secure. But as you'll see, actually, there are still vulnerabilities, right? As it says, we're currently getting down to about, fixing 10 of these per release. So there are the numbers in chart form. 2013. I can't do the Latin thing, but really bad, and then it got better. Okay. So the stats of those things are, yes, a lot are in the applet and browser space, and there's and also untrusted, and we'll talk about that in a second. Untrusted code, untrusted data, cryptographic, and a few others. So there's still stuff locking around. Let's just move on. So let's talk about how they get in. Untrusted code. Untrusted code is literally that, is bypassing your security manager. I find ways around it. They talk about client side, but actually it's server side as well. There are lots of places where you can these vulnerabilities come out. And again, they're all classified. Like you have partial bypasses, where you can get at some information, full bypasses where you can get at the code, right? Vulnerabilities that let you run things as root, right? And the only really good news is, of course, with applets going away, a lot of those attack vectors are being removed. But untrusted code is still potentially possible, right? So I think in the interest of time, I'll move on from that one. Untrusted data. So this is where data comes into your system and you don't validate it, right? That's the thing, right? We're very good at writing code that's flexible and without checking the data that comes through. So that means people will find vulnerabilities in that and exploit you. They'll realize that you are uploading data you're not validating, and you're assuming it's in some standard form, and maybe you then execute it, or it's a SQL query, those sorts of things, right? The cryptographic ones are in various places. There are obvious places where people have realized that the cryptographic process is broken and you need to upgrade. There's some examples of that. But there are also places where cryptographic is also about exploiting the weaknesses in the cryptographic code, not just about the fact that it's the cryptographic algorithm is broken. It's also there are vulnerabilities in that code as well. So they can get lumped together. Then there's local attacks where you've given people access, and because it's useful to give people root access, etc., because it makes your life easier, you then run the risk of the person you've given it to doing something that they shouldn't do, inserting code. There is a fraction of people out in the world who will take money because they have a grudge against their company and would insert things like that. Okay, so loads of vectors, right? Let's talk about serialization. That's the best one. I love this. So serialization has got a special place in my heart because it's so full of nice places for working around things. Because of the design of serialization, people forget that when you deserialize objects using serialization, you're driving a code path that is not the same as if you constructed the object. Okay, deserialization bypasses a lot of checks unless you specifically done something about it. So this one, what they call gadget chains, this shows you why this stuff is not a smoking gun. So the example would be, what should we use? So let's suppose that you can find a piece of code that calls runtime.exec, right? Like Apache Commons. Okay, but it doesn't have to be Apache Commons. It's just the basic problem of I find a piece of code that calls runtime.exec. So I can construct through serialization chains because you're not checking them, you're just getting a serialization data in, and you just go, construct data, construct data, construct data. I can construct an object for anything that's on your class path. So if I can find out what's on your class path, or I just do it on spec, I keep trying it, I can construct quite complex objects, right, through these serialization gadget chains. I'm not running any code, unless maybe you've got some specialized code running when you deserialize. But at the end of the day, it's a way of being able to get your arbitrary string being executed by a code. So if I can find some code that will take some, that I say, here's a class that's got some data in that I want you to run, then if I can construct that class using serialization, then I can get you to do something. Okay. So I don't know much about what's happening in 290, but Tim, you got anything to say about 290?
I'll just say that it's going to be whitelisting of classes which you're allowed to load through serialization. So there'll be a mechanism that you can put into, it'll be part of the base Java, but also then part of applications where you can say these are the only types of classes I'm allowed to be deserialized.
So that should help. provided you guys make use of whitelisting, and yeah. And again, the tension is, from a vulnerability point of view, is that these technologies, we're doing things to fix them, but developers are very good at making things flexible, and it's the flexibility that can bite you. So that's all very dry. Attack vectors and processes and things like that. So we have some examples. Now, I have a few examples. Look, it says examples. We are not going to put up CV numbers. I'm not going to point you at code. I'm going to try and be as obscure as possible so that if you haven't had this thing fixed, you need to go get it fixed. So all of these examples, there's some of the stuff you can go Google for, right? So here's a really good example. This is one around for ages. This researcher found that by doing the right sort of calculation, you could hang the CPU. So was it that just putting the number in? There's some calculations involved, but you end up going, if I can get this number into your system, then I will hang your computer, right? And it was everywhere. And of course, it's a.
So to be passed in as part of an XML document.
Yeah, it could be passed in as an XML document. It could be anywhere. This number could get in, and so somebody could be on. It could be anything. You could calculate it and pass it in, or it could be passed in, and at the end of the day, your system hangs, right? That was a good one, right? And you've got denial of service attack out of that. Really simple one. If I can get the number to you, the important thing is CVS score was low, okay? Because people don't always understand the consequences of the problem. So you have to be, checking these things. So we spent a lot of money, everybody spent a lot of money fixing this because it was so easy to create. Once people knew it was available and how to do it, we knew that there was going to be a lot of people trying to make it happen. Okay. So here's the next one, Patti Struts, mishandling of request data, right? Untrusted, as it says, untrusted string data passed into runtime exec. But it's not easy to describe because it was a series of events that took place to get to the point where that would go wrong, okay? The thing about this one that stands out is that it was exploited, right? And as soon as somebody said, I have a fix for something, right? If you sort of go, I have a fix for a really complicated, dangerous problem, people will be watching. Once they know that that problem exists, then, as I said, there's like giving you credit card details. Eventually, you have to fess up and say, I've got a fix for a problem. And if I tell you it's a really bad problem, then you know by consequence of that will be there will be a lot of people who are going, how can I exploit it, right? So it was actively exploited straight away, and it was easy to find secure vulnerable servers. Another one of these, you've got a vulnerability in your system, and I can find that you've got it, and I can exploit it quickly, right? And another characteristic of the vulnerability problem is that it can be in all sorts of code. It can get copied, it can get reused, there are variations of it, and it can spread around, which is why we have the CVE process in the first place, is so that you can at least track that problem. Somebody fesses up and said they fixed it, you now know the problem has been fixed in that space, and because it's the same common problem. Even if you're not sure of the details, at least you can track the specifics. Then there are examples where we're just silly. jdwp. This is a great tool for people to use if you want to debug. However, it's not good to let that port be available publicly, right? Because people can then connect to your server, and they can read all your data, and they can make your code do whatever they want because they have access to the debug console, right? Found by a researcher after a simple port scan, right? Nowadays, port scanning is obviously something that happens instantly. Nowadays, if you deploy a new server on the internet, you can expect to be probed within 15 seconds, and you can expect to have a targeted attack within 40 minutes, right? So these sorts of things are you just can't do that, right? The trouble is, of course, you don't realize you're doing it, or you're doing it because it's the right thing to do for you as a developer, right? bad thing to do. Right. DLL sideloading vulnerabilities. It's the same thing as all these others. Is I found a hole in your code, right, where you're being useful and you're saying, yeah, type in here what you want me to do. Give me the full path of something I want to do. And an exploit in that is connect. So it's a code exploit connected to you writing some code to allow generic things to happen. And because you're not thinking about that consequence of if anybody can do this, they can do they can do bad things. You end up with situations where you get malicious code planted because you've given people access to things, right? So this is the similar sorts of problems as that we all talk about. We know about SQL injection and how you're supposed to be validating the data, okay? So we get that, but actually everything where you're using data that is from your system or from other machines, you should be thinking very hard about how you're validating the data, constraining it, right? And every time that you create some cool tool that allows somebody to do cool developer stuff, think about the consequences and how you lock that down so it's not actually accessible at runtime or at production time. Okay. So I said vulnerability is a bug, right, which can be exploited by attacker. It's also a feature. If you've written a feature, that could also be a vulnerability. And also, as I've just said, is anything that you add into this system for your benefits can also be a vulnerability, right? Because people will exploit what you're doing to help yourself. And it's a very classic way nowadays for getting into systems is to find the developer backdoors that they've added, right? Which you may easily share with other people, right? So that's the anatomy of vulnerabilities. I said I've got 15 minutes left because I was assuming you guys were going to ask me questions. So either I talk too fast or you're enthralled or what? So, summary. You have to keep current. Absolutely nowadays, right? You need to be getting your systems to the point where all that can be exploited are what they call zero-day vulnerabilities, which are ones that have just been discovered. Right? If your system relies on old software that has known vulnerabilities, then you are at risk. So keeping current is the most important thing to do. And I know people will go, well, I can't keep current because I have to test things. Well, because of the fact that we have some really nasty people out there trying to exploit you, you have to get the balance right. Okay. Yeah, JDKs have an expiry date built in. Yes. So they explode. They stop running. Yeah. Yeah. So I'd say, keep current. Compartmentalize is another good way around this. We do things like microservice design stuff, which are beginning to help in sort of incidental ways. But actually, you've got to be thinking about not having people have full access to everything and how you construct your application so that you keep the separation. As it's the bulkhead idea. Don't let people in have access to everything. So I said microservices are really cool ways of separating that, and things like Docker and that will give you that compartmentalization by default. But, sorry, somebody's putting their hands up. Yes?
I just think that things like that Java debugs are very useful, but you can actually lock it down just by IP address, because you know your own IP address.
Yeah.
Lock it down to that.
Yeah.
And then surely that's going to be fairly secure, at least while you're actually...
So I think your assertion is that you can easily lock down JWP because you know the address. Absolutely. But that bank didn't, right? It's not, you're totally right that you can secure these things, but it's the fact that people don't. And they either don't because they... Yeah, dev versus ops, but actually people don't realize. When you give an ops team some code and they run it and it says, I've got some ports open, they may not challenge you. Mind you, some ITs will go, shops will not let you open any ports. Yeah. Yes, so compartmentalize, design for intrusion. Start thinking hard about whether what you'll be doing in terms of helping people and helping yourself is giving away too much information and how it could be exploited. Once you start to get your head around how you're, put your own white hat on and start thinking about when you write code, how much of the helpfulness, the genericizing, the I can do anything here approach is going to make you vulnerable. Right? And I would also suggest, in general, that you go learn about penetration testing. It's not a Java thing, but when you go see what the guys do to, professional penetrators who are looking to get into your system, happens a lot, they will show you how they get in. And you'll be quite surprised at some of the easy things they do to get in and some of the social engineering they do to get you to give some of the secrets up. Because you may think you're very secure, but actually, generally these guys are very good at wrinkling out those edges. So if you go see the basics that they do, then that gives you the more information about how you would construct your system so that you're less vulnerable, right? And again, sorry, there's a hand at the back, but please.
So how do you feel about some of those
Static code analyzers. How do I feel about static code analyzers? Okay, so I think they're good. We use them. I like static code analyzers that you have ways to turn off false positives. Right, so that's my history with static analyzers, is static analyzers that warn you about the same thing over and over again, which you go, yes, I accept, then you get noise, and then the tooling becomes less useful because you've then got to sort out the new warnings from the old warnings. But in general, yeah, absolutely, any of these systems that can help you identify issues. I mean, you get vulnerabilities because you're not doing quite the right bounds checking around when you're processing arrays and things like that. So static code that will tell you that you've got potential bugs or you're not accessing all the code correctly will help you identify whether you've got, sorts of vulnerability.
It catches the low-level stuff.
Yes. Yeah, Tim says it's like lint. It catches the low-level stuff. Yeah. There are people you can pay who will come in and review your code and tell you whether or not you have vulnerabilities. I'm not sure if they tell you what the vulnerability is, but there we go, yeah. All right. So technically, I think I've said most of this stuff. Don't write custom stuff unless you know what you're doing, right? Don't write the very, very, very trusted trust manager, please. Just don't do that one. Think about, I mean, what can I say? You know these things, right? You know about what's happening here. You've heard all about bad serialization and how vulnerabilities get in. The takeaway is that it's not evident, which is never evident to you when you write code, unless you're thinking about it right at the beginning. Why am I doing this? What bad things can happen? Okay. Because if you've put your happy hat on and go, this is really cool, I can do all these cool stuff, of course you can. But possibly so can other people who exploit that, right? So when you're writing your custom crypto code, don't do that. When you're writing your custom XML parsers, all these things, if bypassing the security systems are bad things to do, turning them off, which is another classic, it's not only about things like writing the very, very trusted security manager, it's other things outside Java per se, but it's like using wget and turning off SSL checking or any of these tools. Getting code from Maven repositories without thinking about security. These are all important things. When you download the next version of something from Maven Central, what do you have in terms of your processes checked to see what CVEs have been addressed in that, right? And I suspect the answer is you haven't even been thinking about it, right? So again, that's it. Thank you very much for listening to the vulnerability rant. Are there any questions? Do you feel more informed? Are you going to go away and write more secure code? Good, thank you. I will put these slides up on slide share.
Have you seen the company Warratec? They have a JVM solution where they effectively run a JVM inside a JVM. And they do this in order to be able to run more unsecure, older JVMs such as Java 6 or Java 7 that are unpatched inside a wrapped, up-to-date, nicely patched Java machine. Have you seen all of that at all? Or?
So have I heard of Warratec? Yes. Have I seen any of that specific stuff? No, not personally. Tim's nodding his head. Do you want to?
So I haven't used it in anger, but yeah, I'm aware of Warratec, and we have spoken to those guys. It's a very interesting solution. So it's kind of, like you say, it's kind of virtualized environment, so it kind of fits in with some of the other stuff that we're doing back in the day for virtualized VMs. But I haven't used it in anger, so I don't know how successfully it works in production.
I think it's all the stuff is good. I see people chucking large amount of money to solve some of these problems in quite weird ways, like, you know, the ideas like having encrypted JVMs and things. But actually, so much of this is just really simple. So much of the vulnerabilities are not realizing that that little bit of code. I mean, to be honest, a lot of this stuff you wouldn't even we wouldn't write it. You'd write the code and go, what's wrong with that? Right? And it's the fact that somebody else is chaining these things together. I think so many of the vulnerabilities that I've seen are all of that really straightforward thing. All those really weird things with the double number. I mean, you're never going to spot that one. So I'd say the takeaway is not go get really big solutions to the problem. The thing is to educate yourself to the way you design and write your code so that you're more aware of the consequences of your actions from a developer point, from a security point of view. Yeah.
Is it worth me just spending a couple of minutes talking about how we do it at IBM, I guess, because
we've got a capture
being a large company, of course, there's a process around the whole development cycle. And so as Steve was saying, people feed in security issues into our deliverable from a variety of different channels. So obviously we're receiving things from external researchers. And were those links live, the underlined links that you had in your presentation?
Yes.
Because the link for sending vulnerability reports to Oracle, I think is SecAlert, is that right? At oracle.com. IBM is pcert at IBM.com, I believe.
Yeah.
The OpenJDK project is starting up a vulnerabilities group where you'll be able to report things into the open source project, but without making it publicly available for everybody to see. It'll be made available just to a core team at OpenJDK who can then work on the solution. Yeah. So we get some reports in that way, but obviously a lot of the code is being originally authored by folks inside IBM and the large companies. And so we do have a process around what happens when you're developing a new feature, and the developers will have a design for it. They'll be working on it, and they'll be asked certain questions about the nature of the feature that they're adding. So such things as, are you accepting data from an untrusted source? And so, of course, that has to be flagged as being, what's the word I'm looking for? I think that has to be cleaned before it's used inside the system. There's a word for it, I forget what it is. I've just got back.
He just got back.
Are you handling sensitive data in flight or statically managed on disk or across network communication? And so you have to actually encrypt and decrypt some of that stuff. And so there's a whole bunch of kind of different areas in which we check whether the features that are being added in there have a security impact around them. And so we kind of have a secure engineering practice. Another step that you have to ensure is that if you have any dependencies, if you're adding in any dependencies into the application from a third party, then it actually triggers a whole bunch of new systems where we, as Steve mentioned earlier, we do like a pedigree review to find out who wrote that code, not only because we're interested in the license to allow us to reuse it, but also was it written in a manner which is going to adhere to our secure engineering standards as well. And so we'll end up doing some reviews on those codes, depending on where they come from. Because obviously a lot of the products that IBM has and we pass downstream will be warranted by IBM. So if there's any problems in the third-party code, it actually comes back to our responsibility to get those things fixed or be responsible for the losses that the company that's using it may have suffered. Again, as Steve mentioned, any third-party dependencies, you can do that analysis at a point in time, but you'll be expected to keep that up to date. And so there's an ongoing mechanism by which we have to ensure that we're monitoring for any vulnerabilities which are in those. And then finally, once it all gets put together, once the features are being delivered and shipped as part of the product, then there's a general security testing where we do the static analysis, and we have other folks who look at the overall security of the system to make sure it works well. So the point is, yes, there's a role for a developer, but it's part of a much bigger process of ensuring the security of the entire system end to end.
Yeah. Okay, thank you. So I have a question for the audience. So we put this together based on what we thought people would be interested in terms of Java vulnerabilities. Have I missed anything out? Is there anything that you would like to have heard that we didn't cover? Apart from us giving you total examples of real code. Okay, cool. Okay, so there's a question?
Yeah, are there any tools to automate what you were just describing there about checking for, so like, are there any tools for Nathan or Grader?
So, yeah, are the tools to check against the CVE database? Yeah, it was fine. So they're beginning to turn up. So I mean, our cloud has some stuff built in, but Docker, for instance, has checks where they will list the vulnerabilities. Now, I don't know whether it's got down to Maven on the recent. Sorry. Version I.
So there is quite a good product that I've seen called Version I, which keeps track of. So you can point it at a POM file, and it'll go through the full sort of trans-disclosure of your dependencies, and look at the versions and report back to you whether that's got any known vulnerabilities in any of those versions.
Yeah. Cool. Thank you. Does that answer the question? Yeah. Cool. Thanks. Okay. Well, this is 1 minute. Thank you very much. I will give you 1 minute back. Thank you for listening.